So, all right. Welcome to another CyberSec Tuesday. Tonight we have myself going to be doing a workshop on Python. It's going to be getting started with Python for cybersecurity professionals. Quick shot before we get started. I do want to do a sponsor tease. We are No44 here is sponsored by a cybersecurity consulting company called ArcLight 6. They deliver risk-based security first engineering solutions that protect companies' systems from the ground up. And if you're interested in checking them out for to hire, whether it's going to be for cybersecurity integration, software development, or compliance, check out their website, arclight6.com. And yeah, so me getting started with the workshop tonight, just to let everybody know here, there's a couple, we're going to be doing this as like kind of an open discussion. So as I go and kind of introduce everybody to Python to those that are new to it, feel free to interrupt me if you have any questions or if you are stuck with any issues. The only requirement for tonight is needing to have Python 3.10 or above installed. Honestly, if you have an older version of Python like 3.8, I think it will be fine as well as an IDE like VS Code or PyCharm or Sublime Text, something like that. I'm gonna make this a little interactive too, not too much, but I might ask you guys some questions. The first one is, who here is new to Python? Who's maybe interested in learning but have never used it before? Feel free to drop it in the text channel too if you don't want to get off mic. Um,
Crozen says used it but confused. Robbie is new to Python.
cool. Well, yeah. Um, so Python. I'm gonna give you kind of a brief history on it. And get my notes real quick. So, um, Python is a scripted language. It's open source. It's developed by developer named, or originally developed by developer named Guido van Ross. It was created back, I believe, in like the early '90s. And it's really popular in the cybersecurity community because since it's a scriptable language, you don't need to compile it. It's easy to work with. It's easy to write up quick scripts to get things done. The standard library, which is like the packages that it comes with, is very diverse and expansive. And whatever the standard library doesn't support, there are plenty of third-party libraries that are out there. Um, so that's a little bit of the basics. Let me pull up my notes real quick. 1 second. Everybody can see my screen all right.
Yes,
VS
indeed.
Code terminal. Okay, cool. So I don't have any slide decks. I apologize if this is getting a little last minute. So yeah,
Question.
go back to like, oh yeah, go ahead.
So is it advisable as we see what you're doing to do VS Code, or it totally doesn't matter?
It doesn't really matter, but if you want to, I mean, yeah, it doesn't really matter. I might go into a little bit of the VS Code stuff, but
Okay.
yeah, I mean, VS Code, I would say is probably preferred in my opinion, at least for this demo. But whatever, I'll mention anything that might be VS Code specific. And you can use VS Codium. There's tons of other open source VS Code forks, so I think any of those will work as well too. So, I might show off some cool things that are in VS Code, but the main focus here is mostly going to be around Python. So going back to what Python is, it's general purpose programming language. It's high level. It's interpreted. which means it doesn't need to be compiled, and it's easy to use, which is why it's so popular. Most folks use it in not just scripting, but automation, data analysis, AI, um, using it for yeah, pretty much anything. You can build websites with it. You can build, if we're talking about cybersecurity, you can build out tools that interact with APIs. I'll be showing some demos on how to do port scanning with Python, how to do simple hash cracking, how to do log analysis, how to set up a reverse shell. A couple things. Those will be some of the demos I'll do later, as some of the like the practical examples. And I'm hoping to keep this around an hour and a half. Hopefully, no more than that. Like I mentioned, feel free to come off mic and ask me any questions as we go on. So I have here, this is VS Code for those that aren't familiar. I'm going to open up the terminal here too, just to show you guys how Python works from the command line a little bit, as well as from the IDE itself. So I have Python installed, so we can just do a Python dash version and wait, Python 3. Depending on if Python's installed on your system by default or you installed it after the fact, you may have to do Python or Python 3 as the executable to or the binary to call it. But you can see here Python 3 dash version gave me the version, which is Python 3.10, which is what I have installed. That's like I mentioned, it doesn't really matter as long as you have something like 3 and above or 3.8 and above. So, so going through a couple of the main things you want to know when using Python. When you work in Python, depending on how advanced you want to get, you will typically be installing packages. Packages are like libraries that that have pre-written code that lets you do more than what the standard Python library has in place. So one example is, VirusTotal, for example, they have a Python library that lets you interact with their API easily. If you're working with AWS, they have a library called Boto 3 that's designed for interacting with the APIs for AWS. There's tons of libraries out there. I'm going to open up a browser here, but if we go to PyPy .org, this is actually a site you can find all the different packages that Python has publicly through this repository. There are, of course, other repositories out there, but this is the most popular one. And this is typically installed. This is you interact with PyPy from the command line via pip, which I'll show off in a bit. So going back here, the first thing to kind of you want to do whenever you're going to work on a new project, and here I have a project. I have a folder I created called the Python Workshop. I have some files in here, and then I have a file called test.py. This is going to be my project folder, and in here I just have some Python files. That's it as right now. When working with on a cabinet, like a folder that's going to be dedicated for projects, that you're going to have a bunch of scripts in, or either whether it's one script or a whole entire program, you want to keep it typically in a single directory. And if you're going to interact with other third-party packages out there, or just doing development on your own, you're going to want to use a thing called a virtual environment. What this does is it isolates your project's dependencies. When I say dependencies, those are libraries or packages. And this will avoid conflicting with your system's default installed Python packages. A lot of systems like Mac OS or Linux, and I think sometimes even Windows, might have Python installed by default, or maybe Python was installed by a program that you downloaded. and they might have packages that are installed on the system itself. You don't want to mess with those because you can actually break functionality on your operating system or other pieces of software. Vinci, do you mind um, muting your mic? Cool, appreciate it. So virtual environments. So if you have Python 3 installed, you're more than likely going to have pip installed. So we'll go over that in a sec. So to get the virtual environments installed on your inside your project here is we'll run Python 3 -m, and that's what this does is allows us to load in a module. And by default, all or most Python installs will have VENV, which stands for virtual environment installed. So we run this. We're going to give it a name of our virtual environment file, our full directory. Sorry, which is I usually name it. Most people name it .benv or .benv. You can actually name it whatever you want. So people, yeah, it just depends on whatever. There's really no like right or wrong way to do it. But I usually just call it, BENV for my virtual environment. So I'm going to run the command, and what you're going to see here is I'm going to get this directory installed. And in here, if I open it up, we're going to have some binaries. Like we're going to have the Python 3 binaries. We're going to have these other scripts in here too, and then this lib directory. And as you install packages on your system for this quote unquote project, they will all be installed inside this lib directory, and it just keeps things organized. It prevents you from modifying your system's pre-installed libraries and whatnot. So it's really important. You want to use this across all projects. This VNV or virtual env, you might hear these names kind of like interchangeably. They all do roughly the same thing, and there are other like virtual environment solutions out there, but this one's, I'd say, is the most popular. Does anybody have any questions before I move forward? All right, cool. So that gets the virtual environment installed. I'm actually going to let this deactivate. So if you're already in a virtual environment, oops. There you go. So right now,
I do have one comment.
Yeah, go ahead.
So one thing that I discovered is learning about this virtual environment stuff. Basically, yeah, it's all about this pip program that you run, and there's really 3 levels of running it that I've noticed, and it has to do with scope of what it'll affect. So just like you were saying, you got to be careful about how you run it. Like in what context you sort of run it. But I've noticed there's 3 contexts. There's you can run it as root, right, to install packages via pip. That's global across your system. Then you can run it as a regular user, and that's just going to affect you as a user. And those are both outside of virtual environments, like VENV. Poetry is another one, I guess. There's different ones you can use. And then the thing that Synack here is showing us, which is basically what you're going to want to do for every project. And so anyway, there's 3 levels, and it's important to keep in mind that there's different sort of scopes to that. So there you go.
Yeah, and I'd say getting started is just focus on using virtual environments, just so you don't break anything on your system. So going forward, so right now I'm on Linux. By the way, I'm on Ubuntu 22.04. So this is my terminal. I don't think I have anything installed. My terminal this is all default. And so one thing, once you have the virtual environment that are installed, which I did by running the last command, you want to actually activate it and enter into the virtual environment. So what you can do is you can either put in the word source, or you can just put dot, which is the same thing on Linux. Unfortunately, if you're on Windows, I'm not showing how to do it on Windows. I don't have a Windows system to show. But if you're using like WSL on Windows, these commands should all work the same way. If you're using just the Windows PowerShell command line, it's going to be a little bit different. You will notice that there is a activate.ps1 file in here that is for PowerShell, but I'm not going to show that because I just don't have an example right now. So, but as I was saying, I want to I can either use a dot or I can use the word source. So for this sample, I'll just use source, and I'm going to go to my virtual environment directory, to the bin directory for binaries, and then I am going to go to the activate. What is this? A binary in here, and when I run this, you'll see this VENV on the left hand side of my terminal. This is telling me that I am now in the virtual environment. If I do a which Python, it should show me that the Python that the Python binary that I'm using is actually going to be the one that's in my virtual environment. If I deactivate to get out, if you run the deactivate command to get out of the virtual environment, and I ran which Python 3, you'll see. Why is it showing the same one? Oh, you know what? I think it's because this. Let me delete this real quick. So I set this up kind of prior to this meeting, but damn it, I'm not to do it in VS Code. And so virtual environments, if you're using VS Code, yeah, VS Code does support Python virtual environments. You can actually set your VS Code to use the virtual environment by coming down here. I'm not sure how to clear mine. Let me see if I can figure it out real quick. Virtual. I do not. It's okay. So if you do to let VS Code know about your virtual environment, you can come down here, and you by default you probably won't have the VNV directory displayed here. You might have these defaults down below, which if I click on one of these and I reran the command, I don't know why it's not showing the other one. But what you want to do is you can actually add in your virtual environment that you created by going into here, enter virtual environment path, browse, and then what you can do is come in here and click on one of these. And what I'll do is let VS Code know about your virtual environment. And the reason you want that is that when we start writing up Python scripts, having VS Code be aware of your virtual environment will allow it to know where the packages are installed. And when you like run the scripts, it will just know where to grab those packages. Otherwise, it's not going to have any clue. So that's what that option is for. Does that make sense? Anybody have any questions on that one? Okay.
Wait, how did you bring it up to set that?
You just click on it and it'll pop up an option here, and you can enter your
It
interpreter
just says
path.
select interpreter.
You should have an option that says enter interpreter path.
You just clicked on that search box or something, and that popped up, or did you search on something?
I just clicked down here.
Oh,
You
All
can
right.
also come up here and type in virtual. I think how you do it via the command line or via this. Oh yeah, so you type in VNV up here in this box at the top. You can actually create a virtual environment. But you should be able to just select one right here. PyCharm, or sorry, sorry, I usually use PyCharm. So if you hear me accidentally say PyCharm, I mean VS Code, but sometimes VS Code will actually pick up automatically your virtual environment. So sometimes you may not have to add it. So yeah. So I know this part can be a little confusing. Virtual environments are a little confusing at first, but trust me, once you start using them, they're really useful. So So now that well, I'm gonna go back into my virtual environment. So now that I'm in here, I'm gonna clear this. And as I mentioned before, to download packages, third-party packages onto your system from PyPy, the repository, you can use the built-in pip command. So it's just pip. These are the different command line options you got here. For example, if I want to install, one I use a lot is Scapy. So that's for like network packet modifications. You can do a pip install Scapy or Scapy, and you'll see this will start installing it. And now you can see under the virtual environment, under the lib directory, under site packages, you'll see Scapy is installed here. And that's just doing a pip install Scapy. If you want to remove it, I believe it's just uninstall. Yeah, and it's going to ask you, do you want to remove it? And you'll see once that is done, that should disappear. I'm going to refresh it. Yeah, so so that gives you some visibility of like how the packages are being installed or whatnot. So as of right now, I think for the demos I'll be doing today, I don't think we're going to be installing any third-party packages. But if you need to, for whatever reason, this is how you would do it. So that's kind of it for the like more complicated parts. I'm going to jump into like the basics now for Python. So I am going to close this or bring this down, and now I have opened here a test.py file. .py is the extension for Python files. And from here, I'm just going to show you kind of like how to do variables, how to set up for loops, how to print, things like that. If you're using VS Code, one cool feature that it has is a feature of automatic installed tool called Jupyter Notebooks. Jupyter Notebooks is a package that can be installed from PyPy, but with VS Code, it actually has integration with it by default. Jupyter Notebooks, what's cool about them is you can actually run Python in what are called cells inside of your file here. So instead of like writing some code and then saving it and then running it from the command line or executing it from this run here, you can run it in a cell based method. And there's a lot of functionality in it. I'm just scratching the surface, but I'll show you actually how to use it if you're using the VS Code. So typically to activate the Jupyter Notebooks piece of it, you can do there's different ways to do it. The easiest way I do it is I use the hashtag and with 2%, and you'll see that I get this option, or I see this run cell feature in here. You may, if you do this and if you do the pound %%, you might get a pop-up asking you to install a Python kernel or install a extension for VS Code. Just hit yes, and it will move you along. I have this already installed, so I have this Jupyter notebook that's installed as an extension. And actually, if you're using Python on VS Code, another extension you can install is the Python extension. You can literally just come up here and do a search for Python, and you'll have this Python extension here. You can run an install on it, and then I believe by default it installs a Pylance extension as well as a Python debugger extension. So you can see these are installed all from this package. So, and what that does is just it allow VS Code to like have more awareness and give more feedback to you in the text editor for VS Code for we're using Python. So so now that I got this Jupyter notebook set up, I put in this special pound percent that has opened up a cell. And if, for example, if I want to put in a variable, let's say I do a variable test equals hello world, and I go to print this, which I'll kind of go into in a minute here. To run this, I am just going to hit either run cell, and that will give you the output. Oh, see right here, it's asking me, do I want to install this IPyKernel package? I'm gonna hit install, and what this will do is it'll activate the Jupyter notebooks and the behind the scenes. So now that that's installed, you'll see, okay, it did finish and it printed hello world. So you can also do, I think it's control enter, and it will do the same thing. So if you see me, if I say I'm going to run something, I'm probably pressing control enter and it's printing it off on the side. You can do that, or you can say, you can hit run cell as well. The cool thing about using this Jupyter notebook style editing, this is really good for prototyping or experimental, like experimenting with code. You can run code per these cells, and they're separate from one another. So if I put in here print, this is a test script, for example. If I run this cell up here, I'm only going to get this print hello world. But if I run this cell here, I am going to get this as a test script. So hopefully that makes sense. Hopefully this is not too advanced. Like I said, this is a really easy or really useful tool for writing code, especially when you're new to Python. Yeah, so going back to, I know that we're going to go to the very basics here. And the first thing to do with most programming languages is how to use variables. And variables are ways for you to store data. For example, the different types of data that you have with Python, there are many types of data out there. The most common ones are going to be strings. So this is a string of text. If I have there's the other one is going to be a decimal, or sorry, integer. So let's say I have age 25. That's going to be, this is an integer. If I want, there's also a float where you can add in like a decimal value. So I can say decimal number, and if you see this stuff that's automatically appearing on my screen magically, it's because I'm using VS Code and it's got what do you call it? Copilot installed on it by default. I thought I deactivated it. Actually, let me see if I can turn it off because it is kind of annoying. Copilot. I did tell it to turn off earlier, and I think it's enabled itself again. See, disable completions. Okay, that should be better. So yeah, so I floating number, which is with a decimal, is an option here. So here you have a string, here you have a decimal, and then here you have a float value. The other thing is going to be a Boolean, which is either going to be a true or false. So so I'm creating, these are just variables I'm creating, and I'm going to put true here. And yeah, so those are the basic types you're going to be using. From there, more advanced stuff will be lists. So let's say I have create a variable called myList. Lists are going to be in brackets, and they're going to have quotes around them. And they're in a list. This could be a list of items. So I might have an item called 1, another item called 2, and another item called 3. This is a list of items, all separated by quotes with commas. And then I think the last one I'll show you guys before we get into any more advanced stuff would be dictionaries. So dictionaries are going to be surrounded by curly brackets, braces, and they're going to be filled with key values. So this, for example, this will be, I'll call this the key, and this will be the value. So I can put in here age, and they're separated by commas. So age, and I'll put in 25. And inside here, these key values can be floats or strings or decimals, or sorry, integers or booleans. So it is flexible. They can also be lists as well too. So I can say, for example, I can say you can plug in these variables in here in a dict, for example, or even in a list. So if I come over here to my list, I can add in a string and a custom string here that's from this variable test. And then in this dictionary, I can add in, maybe a let's see, float, just the key, just calling it whatever. But I'm going to plug this in as my I'm just gonna close this out as my value here. So now if I want to display these, I can print them. So if I want to print hello world that's from this variable here test, I can do that and I can run this and you'll see hello world. If I want to change this out for printing this age of 25, it will print that out. If I want to have multiple things printed here, like print is security professional, and I'll run this. You'll see I got 25, which is the age here, and then is security professional true showed up here. And yeah, so it's just the basics of variables and different types of data types. Any questions at all? All right. So this is really basic. So what we'll do is we'll go jump into something a little bit more difficult. And this is another useful thing. These are going to be called conditional statements. And with conditional statements, well, one thing when working on Python, if you want to ever add in a note or what we call a comment, you just add a pound sign, and then anything after the pound sign is considered a comment and doesn't get read by the interpreter of the code of Python itself. So I'm just going to show you guys the different types of conditional statements here. There's an if statement, there's a elif, and there is the else. So, and since this is in a comment, it's not going to run. So let's say I want to create something in here that says, like, if I am over the age of 18, I'm going to print out the word adult. Otherwise, I'm going to print out the word minor. So I'm going to grab this variable that I created earlier, and I'm going to create the age of 25. And now I'm going to create a Boolean, or sorry, Boolean, a conditional statement. So I'm going to have if age is greater than or equal to, and this is just basic algebra here, 18, this integer, then I'm going to print the word adult. And if I run this the way it is, you'll see right here that it prints adult. If I change my age value here to 16, for example, and run this, I'm not going to get anything in return. And that's because we don't have any other return. We just say you're over 18, print adults. So let's say you're not over 18. You can say I'm going to say if age is not over, or yeah, if age is not over 18 or equal or over to 18, then I'm going to print out minor. So now if I rerun this, I'm gonna get the word minor here because the age is 16, which is not greater than or equal to 18. If I want to make this a little bit more complex, I can say I can add an LF, and I want to add in some additional logic. So let's say age is, um, you know, it's less than 18, or age is greater than 12, then I'm going to print out teenager. And then what I'll do is else, where if none of this matches, I'm going to say child. So now if the ages is between or it's below 18 or above 12, it's going to print out teenager, otherwise it's going to print child. So if I run this now, you'll see, okay, I'm 16, I am a teenager. If I am, let's say, 8 years old, I am, oh wait, my logic messed up here. Age greater than 12, less than 18. I think my logic here is messed up here. Oh, you know what? There we go. It need to be and. So you can also you can chain different options. What's the best word? Different statements in here together to add to the logic. So so if I'm gonna be this age is gonna be printed as a teenager if it is less than 18 and it's also over the age of 12. So that's why now 8 just was child, changes to 13, I should be a teenager, and then 21, I am an adult. So this is just basic conditional statements. Does that make sense? Anybody have any questions? Okay, cool.
So I had a question.
Yeah.
Whenever you add the pound and the 2% signs, it's like another cell that you are writing on.
It is, yeah.
Oh, okay.
Yeah, and this is like I mentioned, this is a Jupyter notebook thing that's built into VS Code. It does work on PyCharm as well too. So if you don't have this functionality installed, don't worry about it. Just don't use the pound %%. And for example, if we do get rid of these, or actually if we could leave these in, doesn't really matter. This to most interpreters is just going to show up as a comment. If you go to run this by itself and we run this as a script, Python, and then type in test, enter, you're gonna get the same output here as you would get for this whole entire thing. So okay, so moving on to the next thing. The next thing that's really important to learn is for loops. So let's say I have let's just say I have let's just say we have a variable called cats. In cats, we have 23 cats here. So for loops allow you to loop over certain things, whether it's a number, like I'm going to show you in a minute here, or if it's a list, like these, like shown up here above. Actually, what I'll do is I'm going to copy this list and bring it down here. So, so what you can do with a loop is you can actually iterate over each one, and every iteration through each one of these items in you that's in the loop. You can do things like you can print. You can do any kind of logic you want. So this example I'll do is for cat. And then what I want to do is I want to iterate through all the cats. There's 23 cats. What I need to do is use a custom function called range function here. And I'm going to put in the word cats. And what this does here is if you're using VS Code, it will give you, if you highlight over range, it'll tell you what it actually does. And what it does is it produces a sequence of integers starting from 0 all the way up to your number here, which actually is to good to know because since it starts at 0, this example, it's going to print, or it's going to iterate over this 24 times. So if I print cat, so this is for every time we're going over this range of cats here, I'm going to set the variable to cat. So for the first cat, which will be 0, it should be 0. So yeah, for each go through here. Oh, actually, it does go through here. Yeah, okay. So what range does is take this number 23, and each time you iterate over it, you're going to have it's each of these variables is going to be set to a number and then increment it up. So the first iteration is going to be 0. The next iteration is going to be 1, 2, 3, 4, 5, 6, and then all the way up to 22. The reason for 0 is because in Python and most programming languages, calling out items in an iterable. Iterable is something that can be iterated on, like a list can be iterated on. When I say iterated, it means that you can the best way to probably phrase it is you can go, you have kind of like a list of items, and iterating means you go to one item to the next item to the next item to the next item. You're iterating through that list of items. So if I ran this the way it is, you'll see I get for every time this is ran, and it does a print on what this variable is going to be. It's going to be going to iterate through starting at 0, and then 1, 2, 3, 4, 5. If I set this to 5 or 4, so let's say I set this to 4 and run this, you're going to see I get 0 to 3 because the zeros are it's the first one's always starting at 0. That could be a little confusing. I can understand. So the next big one that's more realistic probably is iterating through a list. So I have a list here of items. I have the item, 4 items in this list. Item with a string called 1, a string called 2, a string called 3, and then this test variable. If I go back up here to the test variable, you can see it equals hello world. So if I come here and I say for item, we're just going to say, yeah, for item, this word doesn't really matter. This variable doesn't really matter. It could be for I, it could be for P, it could be for Z. It doesn't really matter. It's what you're going to call the variable as you iterate through it. So if I say for item in my list, and I put in the and you're always going to end this with a colon, and then you're going to always put in you're always going to indent after a colon. You're always going to indent 4 spaces, or you can hit tab on most IDEs and it'll automatically put in those 4 spaces for you. I won't get into the whole spaces versus tab element. I personally use tabs. Don't hate. It's because most IDEs will automatically add in the 4 spaces for you automatically. Depending on the programming language, Python, it does 4 spaces, and that's technically customizable. So here I'm going to iterate through my list of items. So each time I iterate, I'm going to call the set a variable as item as the item on that list of where I'm iterating at. So if I print here, I'm going to print the item. I run this. you're gonna get, it's gonna go through 1, and then number 2, and then 3, and then test. And test equals hello world, and that's why I get that. And when you're iterating like this, the reason you see it print all at once here on the screen is because there's really nothing in here that's saying to set any sort of delay before each print. It's just printing as fast as your CPU, will allow, which is, most CPUs is going to look instantaneous. And so as it goes through each item in the list, it's just printing them. I can come in here and have these print one at a time slowly, if for whatever reason. So I can import a built-in library called Sleep. Or actually it's actually, I think it's going to be it's time. So if I want to import, well, to make this easy, I'll just do import time. And what does import time? What does this import mean? So importing actually means I want to bring in some functionality from a library. Whether that's a library, it's from the standard library. Standard library means a library that's built into Python the way it comes from like the from the factory, or I can import libraries that I downloaded from PyPy using the pip installer. Time is a pre-installed library, so I'm going to use this for this example. And then what I'm going to do is I'm going to say after each time I print an item, I'm going to come in here and do time, and I'm going to call in a function from the time library called sleep. And in here, you can see right here it says the argument I can add is seconds, and it accepts a float. Remember, a float is a decimal value, so by default I can add in just a 1, and it's going to sleep 1 second. I can also add in, since it supports a float, I can also have it be 1.5 seconds. So let's say I run this, you'll see it's going to print 1, and then 1.5 seconds later it's going to print 2, and then 1.5 seconds it's going to print 3, and so on. So that's adding a delay. So this is adding in more customization to my loop. Anybody have any questions? Does that make sense?
What would happen, for example, if you change the value of the test variable and printed the list again?
So if we change this, I'm gonna take this and I'm gonna just copy it, bring it down here, just so it's easy to see for everybody. So if I change this here to to null44 rocks, and I run this again, you'll see that now it will print the new one there. And you could, you can get crafty where you can say, maybe what I want to do is I want to change, and while I'm iterating through this list, I can actually update test to equal something else. So new string. So now I'm going to change this to like 0.5 second now. So if I run this now, you'll see 1, 2, 3, null44. Let's see. Oh, you know what? Actually, well, that's not going to really work. But actually, what I can do here is change this to like item. So yeah, this would print out. This is just replacing the item with that new string. Yeah, you can't change once if you're in the loop. If you're in a for loop, you can't change test in here because it's already in the loop, so that won't work. Yeah. But you could change it here. 2, 3. Wait, hold on. Test. Oh, you know what? Yeah, it actually had to be changed here. What you could do is you wanted to change a certain. This is actually a good thing to know. So if you want to change a certain item in the list, let's say you have this list. It's got four items in here. Let's say I want to change the 4th item in here. So what I can do is I can say my list, and then what I'm going to do is the fourth item. Anytime we count items in a list, we start from 0. So this first item will be 0. The second item will be 1, and 2, and 3. And let's say I want to change item 3 to equal um, pizza, for example. Now it would work. Pizza. Yeah. So now what this is pretty much just doing is saying, okay, item 3 in my list, I'm going to call it something else. And item 3, we're now going to rename as pizza. So if we came over here and we printed my list after that change, you'll see that it's been replaced as pizza. If I change this, and what this is called, this is what I'm doing here is changing the index. So this number here is the index. Index starts with 0, so this will be index 0, index 1, index 2, index 3. So if I change index 0 here to pizza, and I run this, I'm actually going to comment this out here so we don't see that. And I run this here, you'll see that pizza 1 is now pizza, 2, 3, no, 4, 4 rocks. So this is really useful when you want to change things in a list. It'll allow you to customize things. Lists are good places to store items in. So if you want to store like a score, for example, for different individuals, you can use a list for that. Or ideally, what you could do is you could use a dictionary. So if I go back here, I create a dictionary called score. Let's say I have Synack, he's got a score of 50, and then let's say Magus has the score of 100. If I print this score, I can print out. You'll see I'll have Synack is 50, Magus is 100. If I want to, let's say I want to print out just Synack's score, I'm going to use just like kind of how we use the index to pick up a certain item from this list here. I am going to pick a certain key from this dictionary. So what I can do is with the brackets, instead of giving it an index number, I'm going to give it a key. So here I'm going to say Synack is my key. So now when I print this, it should print out just 50, which is my score. So hopefully that makes sense. If I want to print out Magus's score, you'll see it prints out here as 100. And then one thing I didn't show up here too is if I wanted to print a single item from my list. So I have my list here, and I want to print out. Let's say I want to print out the second item in my list. I am going to use the index of 1 because it goes 0, then 1. 1's the second item in that list. If I print that here, you'll see I get the result as 2, which is the second item in that list here. So, is that any questions? All right, I will move on to
note, really, actually. So
Yeah.
very important when dealing with dictionary in the key value pairs. The key must be an immutable data type. So you cannot have a key that is a variable. That's it.
Yeah, it's a good point.
Couldn't you have a
last
key?
thing I'll show you.
Couldn't you have a key as a variable as long as the variable that you're referencing evaluates just the key?
So if we come here, yeah, we do. So we have like test equals 100.
Like if it was a string?
And you had test is the key here. You could print or print score equals test, and that would print out 50. So you could call it that way. Is where the key is equaling some sort of value from a that's a variable. So if you change this to 101, it will still print here. But if you change this to, you know, test two, for example, you're not going to get anything printing here.
Yeah,
Oh,
but
actually, oh
yeah,
wait,
but it,
no, sorry.
it's like this. If the key is supposed to be a string, which it was before this, right?
Mhm.
Before you put test in there, it said like Synac or something, and it was a string,
Yeah, yeah,
like a literal string. But you're defining the dictionary, right? But once it's defined, okay, if you're trying to submit a key, right, to look up a value in the dictionary, you would have a string value as like test2, and then when you pass test2, even though you're passing a variable of test2, right, it evaluates to a string, and that's the thing
yeah,
that you need to look it up as, right?
yeah,
Yeah.
yeah. So that would technically work.
As long as it evaluates to what Magos was talking about, which is that
Yeah,
it needs to be an immutable type once it's completely
yeah,
evaluated.
yeah. No, that's a good point.
So your definition of score right there. Yeah, you could do that. Sure, of course.
Yeah. So it's a little bit more advanced, but yeah, I mean, that's a good points to bring up. These are, these almost act as like these variables can be like almost act like placeholders for certain types of text. So, test2 equals Magus. And that's why if you have Magos here and you run this, it will show up because what happens is when you're picking test2 here, this converts to Magus, and this when it's looking at it's looking for that key, it finds, okay, this is Magus here, and then by default it prints the value, which is 100 here. That's why we get 100 here. So, good call out. The last thing I wanted to show real quick too is while loops. This is a really important thing. And this allows you to do something while waiting for something else. So the while loop starts the word while. And let's say I have a count of 200 here. Or let's keep it simple. You just do 5. While count is less than 5, what we'll do is we're going to print the count, and then what we'll do is after it prints the count, we will
You got a typo. Greater than.
oh yeah, sorry. Yeah. While the count is less than 5, we're going to print, and then what we'll do is we're going to increment. What we'll do is as we go through this, and it will start as actually we'll start the 0 as count will be 0, and while the count is less than 5, we're going to print whatever count equals, which by default is 0. Once we do that, we're going to increment the count number by 1. So you can do it this way, or you can do count plus 1. This is a little bit simpler if you just do plus equals a little shortcut. And if we run this, you're going to see we get 1. We're printing this at 0, and then what we'll do is it prints 0, and then it's going to add 1. And it's going to start over again, and it's going to print counts, which was 1, which is now we get 1, and then it's going to add another 1, which is going to make count equals 2, and so on, and it's just going to print it up until it's less than 5. We change this to less than or equal to 5, you'll see that we count all the way up to 5. So this is really useful. You can say, while, something is not true, do X, Y, Z. It's so while, if we say test equals false, if we say test, while test, um, you know, not equal, which is a syntax here, true, you know, what we can say is we can print the count, add counts, and then, for example, we say if count equal two equal signs means if something equals the other thing. If we're actually almost like asking a question here. So if count equals 3, then we're going to make test equal true. And what this will do is we'll run this test right now by default equals false. And this, what we're saying is, well, while test does not equal true, or you can even say while test equals false. There's many ways to do this. There's rights and wrong ways, and I'll show you a shortcut of how to do this in a bit. You can say while test equals false, we're going to print the count. We're going to add the count. And once the count equals 3, we're going to change test to true, and then that will actually cause this to stop because when the test only runs while test equals false. So hopefully that makes sense. So I'm going to run this. You'll see we get to 0, 1, and then 2. And by this time, count is now equaling 3, which test gets added to true. This will no longer run. And now I can put it here, print, or we can say, print finished. So you say once we were done here, and we can even put in here print completed. We can even put in all sorts of things. We can say once.
Can you also
Yeah.
say like while not test or exclamation test?
So yeah, so what you can do too is a shortcut. If you don't doing test equal, this test equal false. There's a syntax called not, and what this does is this is like a shortcut. You can do a while not test, or you can just do while test. And what this means is what this does by default, and this is with like if statements and like while loops and things like that, as is while test by itself. The question it's asking is while test equals true, do something. If we put a not in front of it, say while not test, when we say not, we mean not true, then do this. When we say true, false, we're talking about the booleans. I don't want to get too complex, but an item, a variable can equal a boolean. But let's say you have a test that equals an empty string. This is actually going to return back as empty as well too. So if we say, I know this is a little more complicated, but we come in here and we say while tests, print hello, for example. So we run this. Test doesn't equal anything because it's an empty list, so it's not going to print hello. But if we put something in here, we run this, it's going to take me to run forever. Then it's going to print something because this is actually something. If it's an empty string, it's really nothing. It's just going to result to false. And actually, what it really runs down to, it actually equals none. So if we say if this equals none, and you run this, it's never going to run. But this is getting a little too complex for what I was going to talk about today. But I'll cover this next time. But yeah, just know, whether it's if or not. Let's say I do like if.
Ye-
Um,
Yes, I feel like I'm kind of messed you up. Your prior form of doing the while test equals false was really clear, and
Yeah.
it was a good basic example.
Yeah, so if I go back here to say if I say print if printing to test equals none, for example, if I just get rid of this and I print this, you'll get, if I run this, tests right now doesn't equal anything, so we just get a no because test doesn't equal anything. If I set this true and run this, this will give me yes. If I say false, I'll get a no. If I change this to something like 42 and run this, I'll get a yes because it is a value, which means it will print, it will return as true. So it's a little bit more complicated, a little bit more of an advanced topic, but good thing to pull out. And I put in here not, which means it's the opposite. So if I run this, I'm going to return no because this is not nothing or false. But if I say none, for example, I'm going to get yes. So yeah. Okay, so that concludes my bare bones basics, like getting started with Python. This is just something I wanted to go over with. I wanted to give some real world examples of how you can use Python for cybersecurity. So I have a couple examples of like really basic scripts for a couple cybersecurity tasks that you might run into during your job. So the first one I'm going to go over is a port scanner. So what I'm going to do real quick in the background is I'm going to load up another VM. So that is running. Hopefully my system does not crash. Looks like it is. No. Do you guys still hear me?
Yep.
Okay, cool.
Yes.
All right. System was like locking up a little bit.
Sadness.
Come on. Oh no. I don't know why starting a second VM decides to crash my computer. Let's see, is it gonna work now? Oh, jeez. All right, think we're good on. Okay. Oh no, come on. Yes, can you still see my VS Code screen?
Yes. Well, we can't
Okay.
see VS Code. We could see the Broadcom VMware. I blame Broadcom.
Yeah, playing Rod. Yeah, let's see on. Come on. Okay, I think we're good now. Okay, so going back here. Okay, so what we have here is we have a simple script here, and what we have here from this here, and what this does is we import Socket. Socket is a networking. It's a library from the standard Python library for network socket operations. You highlight over this here, and I'll give you some examples of what it does. So this is a library that's built in. We don't have to download anything. This is just built in. It's just doing very low level network operations. So what we have here, I didn't go over this, but we have a thing called a function. And typically to organize code within Python, you typically would put it into a function or even a class or a method. But that's something we'll say for like the next time we meet up. This just to give a really high level discussion of like what functions are. This function has a name. It's called scan ports, and the name is defined here. And then it kicks in two arguments. These are two values you feed into the function. That's in these brackets here. You have a target, and then you have ports. And then what it does is it's going to print the word scanning, and then the target value, which is going to be an IP address. This is actually the function down here being called out. This is it being defined with this def syntax. This is me calling out the function to be used. So if I have it defined here without if I comment this out, this code won't do anything. But in order for it to do something, I got to call out the function, which is what I do here. And I provided it as a target this IP address, which is another VM I have running, and then I have this range of ports. These ports are in a list. So what this is going to do is it's going to print scanning, then that the target, which is this IP address, and then what it's going to do is go through this list of ports. This is doing a for loop. So this is going to loop through each port, starting with port 22, and then port 80, and then port 443. And for each of those ports, we're going to try to make a connection, a socket connection. I won't get into like this networking piece is a little bit more advanced. But what I'm doing is trying to set up a connection to these ports. And if the connection succeeds and returns a 0, I will print out the word port, example 2280.443 is open. Otherwise, if I can't connect at all, this try and accept, what this does, this is set up here to catch any errors that pop up. And if there is an error that pops up that equals the socket error, which this is a little bit more advanced, I'm not going to go over how this works yet. If this error was caught, it would print out the specific message. If this error was not caught, it wouldn't print out anything. So if I run this now, let's see what happens. So I got here scanning this IP address, and it says port 22 is open. And it's because my VM has SSH open, which is port 22. So this is a very basic port scanning tool. It's like a very basic version of like Nmap, for example. And you can customize this kind of to your heart's extent. I will share this in the channel in case anybody's interested in this. So that's that script. The next one is a script which is for cracking hashes. So here I have, side note, I downloaded this. Somebody have a question?
Yeah, question about the last one.
Yeah.
So you specified 3 separate ports, 2280 and 443, or three separate ports.
Yeah.
So in a Python-y sort of way, right? I don't know if you talked about range. Did you talk about range?
Oh, I did, yeah.
Yeah, isn't there something that like you can do a range or something that'll like expand? Like if you wanted, or was like a list constructor or something. If you just wanted to like say, okay, all ports between 1 and 65535 or whatever the whole range is, like, but you wanted to have it show up as a list, right? And you put that in place of that explicit list of 2280.443. How would you do that in Python? Is that range?
So yeah, so you can use the range function. Okay, I demoed this on the last on my other demo. And what this will do is it will
well, if you left it the way that it was, it's just going to operate on whatever you pass it as a list, right?
Yeah, the
ports, right? So
here.
then what I'm saying is you put it down where the 2280.443 is. Like if you just copy that last scan ports line maybe and make a copy of that whole line, and then you can substitute the 2280.443 with an actual range statement there, right?
Yeah, you can do that as well too. So you can do like range, and I can just say let's say I do 23. So this will do ports 20 or 0, which there's really no port 0, but port 0 through 24, and I run this.
Yeah.
It will automatically scan through ports 0 through 24. In this example.
And the reason why it works, just for everybody else, right, is that if you literally just copy that range 24 thing and put it literally on its own cell and just evaluate it to see what it would show up as, it actually expands to a list, just like you had before. So instead of
Yeah.
having 3 items, it'll have like 25 items, which is like starting at 0 and all the way to 24. So just
Yeah. So
little stuff like that you can do.
yeah. So if you print out what the range looks like here, you'll see that it starts from 0 to 24. And if you wanted to actually set this up, so it's printing from port
But
10
is that
through
is that
24.
is that actually a list object though, or is that a range object?
It's a range object, but it can actually be
Like it's
convert it to like a list event. You can actually get this to
So if you
there
do
you go.
that, so that's what you'd have to wrap it in. You'd have to wrap it instead of saying range 24 or 10, 20 or whatever you did above, right? You'd have to like wrap it in list right there because you have to pass it what that your code, your function is expecting, right? The thing that you call ports, it's expecting as a list. Or
Yeah.
would you have to do that?
Well, so range itself is a function, and if you click into it, and this is actually what the code does. This is actually what the range code does here, which is really, I'm not going to go into it. It's kind of complex for names, but it's a class, and classes create objects, and that's why you got back to the range object. You can convert object depending on the type of object it is. Like if we try to find out what type of object it is, which we put type, we can put type and surround range and type. It'll actually tell us, okay, this object is a range class,
So,
and
so could you get away with passing that scan ports line with it just saying range right there? Like if you're just passing a range, will it actually work in that for loop?
yeah, and it did work earlier. Yeah, so if we did run this
So
here, you'll see that it did work. And if we wanted to see this too, we can actually print the port number, and we run this. You'll see that port 0 through 23 was ran. Remember, lists start at 0. So I put say 24, it's going to go 0 to 23. It's 24 total. You'll see on port 22, it did say it was open.
So basically Python's pretty flexible, right? So instead of literally going, well, but my example here says to pass it a list, right? Which is what you had before, a literal list, and it worked. It's not that it has to be a list. It just has to be something that represents a bunch of values, and it's flexible enough to take either, in this case, a list or a range.
Yeah.
It's flexible.
Very flexible, yeah. And Python, everything's an object in Python. It's more of a kind of a advanced topic, but that's something to keep in mind is everything's an object, and objects can be manipulated. That's the reason why it's object oriented programming language. Everything in Python is considered an object, and every object has ways to be modified through methods, classes, functions, things like that. So I'll move on to the next one. So this next one is a hash cracker. And this is just a basic hash cracking script. And what I do is I have this word list called rocky.txt. Some of you guys might be familiar with it. It's a list of thousands and thousands of words here. And what we're doing is, let's say we collected a hash from a system. This is the hash here, for example. Whether we dumped a hash out of a password database or whatnot. This is the hash we have here. And yeah, I won't go into like how hashes work, what they are, but usually you can get you get hashes represent you take a file, binary, any sort of data. you can run a hashing algorithm against it, whether it's SHA or MD like 5, or there's multiple different types of hashing functions out there, and you convert that item, that thing, into a hash, and it's like a hashing algorithm that's like SHA-256 or whatnot. Yeah, that certain item is never going to have two different items out there that are completely different are never going to have the same SHA hash. I'm not gonna get, like I said, I'm not gonna get into details, but for this example here is, let's say I have a hash that I got. I want to crack it and figure out, okay, what's this password? Is it password, you know, password 123? Is it, summer 2025? Is it some other, BS password? I want to figure that out. So what I'm gonna do is I'm actually gonna brute force this password by going through this Rocky list. And what this is pretty much doing is it's opening up the file here and reading from it, which is what this with open here. This is called with in front of it. It's called a context manager. And what this pretty much does is it will, whatever you say here, like I'm going to open up this file, is when you open the file and you do whatever you're going to do from it, when you're done with it, it's going to automatically close the file, and that just prevents you from having these open handles across your system, which is another topic for another day, but this is the best practice. So what I'm going to do is I'm going to open up this word list path, which this is coming from this function here, which is being defined down here. So I got this hash here, which is hash to crack in this argument, and I got this file here, which is this word list path. My word list is this rocky.txt file, which I showed a minute ago, and I'm going to open it as file. And for each word in the file, which is this for loop, I'm going to strip the word, and I am going to take that word, and I'm going to create a SHA-256 hash out of that word. I'm just summarizing it, in layman's terms for it. And if the hash that gets generated from the word in that list equals the hash that I defined here, then we're going to print out password was found. So going back here, Rocky text, in other words, I'm going to be going through each one of these words here. Michelle here. I'm going to convert this into a SHA-256. I'm going to take that SHA-256 hash and compare it to the one that I provided. And if they don't match, I'm going to move on to the next one until I find the one that does match. So if I run this, you'll see it found that the password is password 123. And if I come over here and do a search, you'll see that was on line 1384. So I went through, 1,383 different options until I got to this one, and this was the correct one. So hopefully that makes sense. This is a pretty basic one, but very useful. When you're doing like CTFs or real life engagements. There are more commercial tools or popular tools like Cat or other options out there. I think Hydra is another one. There's hundreds of thousands of different ones. This is just one option. Say you wanted to create something custom. This is just a good example. Very basic. This other one is called Log Analyzer, and what this one does is it looks through a log file that you give it. So, for example, this var log auth.log file. This is a Linux log file that keeps track of authentication requests against your system, and if there's any failures, it will log it, and that's what we're looking for. So what we're going to do is we're going to open up this path here, and we're going to go line by line and look for this text here. We're taking each line out of the file, converting it to a variable, and if that variable equals incorrect password attempt, then I'm going to print out this statement, potential brute force attempt, and then I'm going to print out the line that it was found on. And I think if my system still has my bad attempt from yesterday. It should work if I run this. So here it is right here. So you'll see that, this yesterday at 8:58 p.m. I made an incorrect password attempt when trying to use the sudo command when attempting to run. I was trying to run the ls command as sudo. In other words, so this is another useful one. And then lastly, and I'm kind of going through fast. I don't want to burn up everybody's evening here. Lastly, what we have here is this as listener script here. And oh, is this right on? Let me triple check. I think this is kind of like the one I did last minute. Let me see real quick if this one works. Oh, actually, this is what I wanted. Okay, so forget what I was showing you a minute ago. What I actually meant to show you was this reverse shell one, and what this does is this is for creating a reverse shell from one system to another system. So from a victim system, we would run this Python script on, and it would connect to my attacker system, for example. So what I'm going to do is I'm going to take this command here, this netcat listen on port 444 command, and I'm hoping this will work. Go back here, and let me just open up this. We're just going to go to my terminal here, and clear this. I'm going to listen on my attacker PC on port 4444. And what I'm going to do is go over to my victim machine. Let's say for some reason you're able to compromise the system and run Python on it. What this is doing here is it's going to create a socket connection using the socket command and this subprocess library, which subprocess allows you to run commands. That's one thing you can do, run commands like from a terminal, for example. And what this will do is create a reverse connection back to my attacker system here on port 444, and it's going to launch the shell binary, sh binary, and so I'm going to run this. So so it's running right now, just hanging out here. If I go back to my attacker system, you'll see that I got this little prompt here. If I type in who am I and print to an IP A to print the IP address, this is the IP address of my victim's system. And then here, if you don't believe me, I'm going to just do a IPA here. And you'll see this is ends in 25.131, which was this system here, 25.131. So I now have a reverse shell into the system as root into this system. And there's many ways to do it. There's thousands of ways to do this exact thing. This is just an example of how to do it in Python with just a few lines of code. So I will copy and share this with you guys too. So anybody have any questions? That's pretty much all I got for today. I don't want to take up too much time. Oh, you guys gonna make it easy on me today? All right, well, I'm sharing all these scripts in the meetup text channel, so you guys can have these. And yeah, I appreciate everybody's time. If you guys have any questions, feel free to ask them now. Otherwise, you can drop them in the chat channel. I can try to answer them there, or we
Got a
can
question.
chat later. Yeah, go ahead.
So I've heard like you like when you were typing Python, you typed Python 3. I've heard of Python 2. other people here might not know about that kind of stuff. Can you elaborate a little bit, maybe on the history of that, and maybe not to get caught up in old versions of Python?
Yeah, I mean, so if you're running on an older system, I don't think it's probably going to be it's common nowadays to find a system with Python 2 installed, but Python 2 is a lot older version of Python. It was installed by default on older versions of like Mac OS and Linux, and Python 2 has been deprecated. It's no longer being supported or has any security patches apply to it anymore. So the whole everybody in the community has moved over to Python 3. And I think now we're on Python 3.13 or 14 now is the latest version. Every version gets new features as well as new security updates, fixing vulnerabilities in the standard library or the ways that it was functioning. So yeah, if you're using Python 3, the syntax, or sorry, if you're using Python 2, the syntax is different than Python 3. So there is actually a command you can use called Python. It's actually let me say it's called Py. It's not installed by default. Well, there was something that was called Py 2-3, and it would allow you to convert Python 2 code to Python 3 code. Worked, some of the time. It wasn't perfect, but yeah, that's one thing. It's hopefully you won't run into it anymore.
And
but-
also, yeah, and then one more thing, like if you go back to that terminal and you just say which Python 3,
yeah,
okay. And so if you had a fresh terminal and you said which Python 3, it would probably say something different if it's outside the VNV.
yeah. So you did like which
So
Python 3 would show you
yeah, and then look at the
systems
two.
Python.
It looks a lot different, right? And so that's part of like what you get when you create and activate a Python virtual environment for a specific project. You're getting it copies Python, right? And it installs it in this little directory and kind of like jails you in that, so you can have a completely different version for your project with completely different little pip3 installed, stuff just for your project that doesn't conflict with all your other shit. So it's just when it's not just Python 3. It's all about the context, right? So you keep a looking on the left there, and it says VENV. When you say Python 3 without anything else on there, you're actually using this local copy, not your main one of your system, which could be a different version.
Yeah. Going back to what I originally said about ideally you want to avoid using the default version of Python that's installed in your system, because like I said, it's going to be tied to certain programs that are installed in your system that are dependent on it. And a lot of times the version of Python that's pre-installed is not it's may not be updated as much. It might be behind. It may be slightly different than like standard Python. So always going through and downloading a new version of Python that's without touching your existing version of Python that comes pre-installed is a recommendation, because you're going to get the latest and greatest. It's going to be supported. It's going to be the real deal. So
Yeah,
something to keep in mind.
Yeah, a virtual environment, or VENV, is like just this little jail. It's like a virtual machine. It's like its own little isolated thing. So you can have stuff in there for your little project, whatever the hell it needs. Maybe a special version of a library, or who knows, whatever, right? You can customize it to your heart's content without jacking up your other projects.
Hey man, it runs on my machine.
Yeah, and then there's Docker.
Works as designed.
So kind of wrapping up things, I wanted to share a couple things with you guys. I don't know if you can still see my screen, but there are some good sites for documentation for Python to learn more. Docs.python.org is the tried and true docs of Python, and there you can learn everything about Python as a whole, the standard library, as well as the PEP standards. PEP, I know I didn't have a chance to talk about those, but PEPs, PEP, those are standards and best practices. They stand for Python Enhanced Proposals, and these are best practices that are proposed by the community and the Python folks on how to write Python the most Pythonically. Python, you'll hear the word Pythonic as a term that's used by doing something that follows the Python community's best practices. Python 8 is the most popular PEP, and it's as a style guide of how they recommend you writing your code. If you're writing your code for just yourself, who cares, I guess. But if you're doing it, you're writing code that's, you're going to share with the team, or you want to better understand or share online, following PEP standards is highly recommended. I'll share a link to that. And then, I will say the Python documentation can be a little overwhelming sometimes. It might be a little sometimes like just the way they explain things, or can be a little over my head, or just worded in ways that aren't, I think, best understood for a lot of people, including myself. So I really recommend a site called realpython.com. This is a really, really, really good site that offers free and some paid options for learning about Python's features. You can learn I think all their text content is free, and then if you want to like listen to their videos, those are a pay for option. So these are really good. I'll drop a link to that. And then outside of that, YouTube, and then our good old friend AI, ChatGPT is really good for learning Python, as well as developing if you're using like Copilot or Amazon Q or Cursor, or the 1,000 other options for AI. But if you're new to Python and you plan on actually using it for work, I highly recommend learning it. There are some good books out there. There's one called Learn Python the Hard Way. It's a really good book that goes into like the how Python works on a lower level to help you better understand how Python works as a whole. There's Black Hat Python, which is a book by No Starch Press that's really good on showing you how to use Python for cybersecurity. And there's thousands of other books out there, so check them out. But yeah, that's it for me. It's
I
late.
got something.
Yeah.
So as a final note, you read my mind. I was literally just pasting the Python the hard way